In this video, we're going to look at how we can solve different sides and angles of a triangle using trigonometry. We're going to start with calculating unknown sides. So in this triangle ABC, we want to calculate BC. We first have to name the sides of the triangle before we can decide which trig function we should use. So if we have a look at this triangle, the angle opposite the right angle is always your hypotenuse. The angle that they've given me in the triangle is 70 degrees. So the side opposite that we're going to call O, which leaves the side AC is going to be your adjacent side. So I want to work out BC, which is the opposite side, and I've been given the hypotenuse. So we should be using sine to calculate the side. So sine of 70 degrees is the opposite side over the hypotenuse. Now, if I want to calculate that opposite side, I want to calculate BC, I need to get 12 on the other side. And I'll do that by multiplying. So 12 sine 70 will give me the length of BC. To calculate BC, I just type it into my calculator exactly as it says on the paper, 12 sine 70. And if I round off to one decimal place, CB is equal to 11,3 centimeters. Let's look at a second example. In triangle PQR, we need to calculate the length of PQ. So if we work with 22 degrees, PQ is going to be my hypotenuse. It's opposite the right angle, which means that PR is my opposite side, and then RQ is my adjacent side. So if I want to calculate my hypotenuse, and I've got the adjacent side, A and H, I should be looking at cos of the angle. So cos of 22 degrees is the adjacent side, so 7,2 over the hypotenuse, which is PQ. Now we need to calculate PQ, so we are going to multiply both sides by PQ. So I'll end up with PQ cos 22 is equal to 7,2. Then to get PQ on its own, I will divide by cos of 22. So to calculate PQ, we're going to go 7,2 divided by cos 22. And if you type it into your calculator exactly as you see it, correct to one decimal place, you'll get 7,8 centimeters. Let's try one more example where we calculate the unknown side. So in triangle LMN, I want to calculate MN. So if we label the sides, LN is my hypotenuse, it's opposite the right angle. And if I use 75 degrees, then LM is going to be my opposite side, which leaves MN as my adjacent side. So I want to calculate MN, which is the adjacent side, and I've been given the opposite side. So the trig function that works with opposite and adjacent is tan. So tan of 75 degrees is the opposite side, so 4,3 over the adjacent side, which is MN. Now we want to calculate MN, so I'm going to multiply by NM and divide by tan 75. So on my calculator, I will go 4,3 divided by tan 75. And we end up with MN is equal to 1,2 meters. Let's see how we can solve some angles using trigonometry. In example number 1, I've got triangle ABC, and they want me to calculate angle A. But before I do that, I need to label the sides of my triangle so that I can decide if I need to use sine, cos, or tan. So the angle opposite my right angle is always the hypotenuse. They want me to calculate angle A, which means that BC will be opposite that angle, and that leaves me with AC, which is the adjacent side. So they've given me the opposite side and the hypotenuse. So which trig function works with opposite and hypotenuse? Well, sine. So the sine of angle A is going to be the opposite side, which is 11,3, over the hypotenuse, which is 12. Now, if you need to calculate the angle using trigonometry, you cannot just say sine of 11,3 over 12. You need to go shift sine. So on your calculator, just remember to push the shift button first if you need to calculate the angle. So shift sine, 11,3 divided by 12, And if I go to 1 decimal place, I'll get angle A is equal to 70 degrees. In example 2, I've got triangle LMN, and I've got LM is 4,3 and MN is 1,2, and we need to calculate angle N. So the first thing we're going to do is give the sides of our triangles the correct names. So the side opposite my right angle will be the hypotenuse. Then I want to calculate angle N, so 4,3 will be opposite that, which means 1,2 is adjacent. So I've been given the opposite side and the adjacent side, so I should use tan to calculate my angle. So if tan is opposite over adjacent, the tan of N is going to be 4,3 over 1,2. And I want to calculate N, I want to calculate the angle. So on my calculator, I'm going to type shift tan, not just tan. So shift tan 4,3 divided by 1,2, or you can use your fraction button, 4,3 over 1,2, and you end up with 74 degrees. Let's try one more. In example 3, we want to calculate angle Q. Now first we need to give the different sides their proper names. So PQ is opposite the right angle, so that will be the hypotenuse. I want to work out angle Q, so PR is opposite that angle, which means RQ is adjacent to that angle. So what information have we been given? We've been given the adjacent side and the hypotenuse, and cos is the function that works with adjacent and hypotenuse. So cos of Q is going to be the adjacent side, so 7,2 over the opposite side, which is 7,8. And on my calculator, we're going to type shift cos, not just cos, we're going to go shift cos of 7,2 over 7,8, or 7,2 divided by 7,8, and we end up with Q is equal to 23 degrees. Let's have a look at one or two questions as they appeared in exams. So now we've got triangle ABC and we want to calculate AB. So what information have we got? We've got AB will be the opposite side. Okay, that's what I want to calculate. I want to calculate the opposite side, and I've been given the hypotenuse, which is opposite the right angle. So which trig function works with opposite and hypotenuse? Sine. So the sine of 29 degrees is going to be the opposite side, so AB, over the hypotenuse, which is 42. And if I want to calculate AB, I'm going to multiply 42 onto the left-hand side. So I get AB is 42 times the sine of 29 degrees. So AB is 20,36 if I round off to 2 decimal places. And we have to calculate BC. Now, there are two ways we can do it. We can either use trigonometry, and BC is my adjacent side, that's its label, that's the remaining label. So if I want my adjacent side, I can either use my hypotenuse or my opposite side, but it's usually safest to use the information you were given. So I'm going to work with the adjacent and the hypotenuse, which means I should be working with cos. Okay, so the cos of 29 degrees is the adjacent side, so BC, over the hypotenuse, which is 42. So if I want to calculate BC, we're going to multiply cos 29 by 42. And if I type that into my calculator, I get 36,73 if I round off to 2 decimal places. There is an alternative, however. Because you already had two sides of the triangle, and it's a right angle triangle, you can use Pythagoras. So the sum of the squares on the two sides will be equal to the sum of the squares on the hypotenuse. In other words, the adjacent side, so BC squared plus 20,36 squared, so the opposite side, will equal 42 squared, the hypotenuse. Right, so don't worry too much about the A, B, and C that I've used. Just remember, if you're trying to calculate one of the sides, you add the square of that side with the square of the other side equal to the square on the hypotenuse. which means if I want a squared, I'm going to take 20,3 over to the other side and square it. So if I go 42 squared minus 20,36 squared on my calculator, I end up with 1349,4704, etc. Don't round off at this stage. Remember, you only round off in your final answer. So if I want to get my final answer, I'm going to square root both sides. So the square root of 1349,4704 gives me 36,73 as well. So you can choose if you want to use trigonometry or if you want to use Pythagoras, if you already have two of the sides. It's up to you. Let's look at question 2. We need to calculate the value of x correct to one decimal place. So we need to calculate the angle. We first need to decide on which trig function to use. And before we can decide on which trig function to use, we need to just give the sides their proper names. So the side opposite the right angle will be the hypotenuse. I'm working with angle x, so AC will be my opposite side, which leaves me with the adjacent side. So which trig function works with hypotenuse and adjacent? Well, it's cos. So the cos of x is equal to 12 over 15. And now because we need to calculate the angle on our calculators, we're going to type in shift cos of 12 over 15. And we end up with 36,9 degrees if I round off to one decimal place. Let's try another example. And this one's slightly different. So I'm given that AB is 1 unit, AC is P units, and BC we don't know. And we need to determine the following in terms of P. We need to determine sine B. Now sine is opposite over hypotenuse. Now let's see if we have enough information. Well, I've got P, that is opposite B, and 1 is the hypotenuse, which does give me sine. So the sine of B is going to be the opposite side, which is P, over the hypotenuse, which is 1. And I can simplify P over 1 to just P. So a slightly different type of question. I haven't given you values this time, but we can still do it quite easily. Next one, we want to calculate BC. Now again, I've got options. We can either use, maybe use trig, but in this case, I think Pythagoras will be a lot easier. So BC is one of the sides, so BC squared plus AC squared will give me my hypotenuse squared. So AC is equal to P and AB is equal to 1. So BC squared plus P squared is equal to 1 squared. If I want to calculate BC, I'm going to take P squared over to the other side. And if I want BC on its own, we're going to square root both sides. And we end up with the square root of 1 minus P squared. But what is very, very important at this point is you have to realize the square root is like a bracket. So I cannot square root 1 and square root P squared. So the square root of 1 minus P squared is my final answer. Leave it like that. And finally, we want to work out tan B for this question. And tan is opposite over adjacent. So the opposite side is P and the adjacent side is BC. So it's going to be P over the square root of 1 minus P squared. You're just going to use the answer that you got in the previous question. Let's try one more. In this example, we've got two triangles. So we'll have to just think carefully about which triangle we're going to use for the different calculations. So first of all, we want to calculate the length of QR. Now we need to decide what information do I need to add to my drawing. Well, I know that PQ is 14 and QS is equal to 20. Okay, so at the moment we're not going to use the QS. Let's just think about the PQ at the moment because we want to calculate QR. So if I look at the triangle on the left-hand side where I've got 51 degrees, PQ will be my hypotenuse and QR will be my adjacent side because PR is opposite the angle that I have. So which trig function works with adjacent and hypotenuse? Well, it's cos. So the cos of 51 degrees is going to be the adjacent side, which is QR, over the hypotenuse, which is 14. And if I want to calculate QR, I'm going to multiply by 14 on the other side. So QR is going to be 14 times the cos of 51. So QR is equal to 8,8 centimeters. 4.2 asks us to calculate the length of RS. Okay, now RS is part of the triangle on the left-hand side. So let's just think about that. So if we want to calculate RS, we do know that QS is equal to 20. And I have just calculated that QR is equal to 8,8. So RS is going to be 20 minus 8,8. So it's equal to 11,2. So I didn't need to use any trigonometry because they told me the whole distance was 20. I'd already worked out part of that side. So I could just subtract to get the remaining part. Question 4.3 asks us to calculate the length of PR. Okay, now the only side or only triangle with an angle in it is the triangle on the left-hand side, triangle QRP. So I want to use that 51. So if I want to use that 51 degrees, PR will be the opposite side. Okay, so if I've got opposite and I want to use the information that was given to me, so I'm going to use the hypotenuse. So which trig function works with opposite and hypotenuse? Sine. So the sine of 51 degrees is opposite over hypotenuse. So the sine of 51 degrees will be PR over 14. And if I want to calculate PR, I'm going to multiply 14 on the left-hand side, type it into my calculator, and I get PR is 10,9 centimeters. Let's look at one final question, and that is to calculate the value of x. Now, to calculate x, we're moving into our triangle on the left-hand side, on the right-hand side, beg your pardon. But what do I know about that triangle? Well, we have calculated RP, which is the opposite side, or PR, and I've calculated RS, which is the adjacent side. So I've got the opposite side and the adjacent side. So we're going to work with tan. So the tan of x is going to be the opposite side, which is 10,9, over the adjacent side, which is 11,2. Now I want to calculate the angles. On my calculator, I'm going to type in shift tan, 10,9 over 11,2. And if I round off to one decimal place, I get 44,2 degrees. Thanks for watching Max Maths. If you liked what you saw, please like, share, and subscribe.